Alright, so let's look at this second lesson. I'm going to change a few things on it, but we're going to go through this front page. And so the main thing that we're going to talk about here on this first page is this thing called a z-score. So this is a really important topic. And so when we talk about z-scores, this thing is going to be used throughout the year, the idea of a z-score. So this is a very important thing. If we need to, when I come back on Monday, hopefully I'm feeling good and can come back Monday, we might spend the whole first half of Monday talking about this and then do the quiz and just be behind on our schedule a little bit because I don't want to miss this part. So this is important. So yeah, we're going to talk about this thing called a z-score. And then we're going to talk about what happens when I add or subtract or multiply or divide values. And I'm going to change the notes up then. But okay, so let's do this first part of this page. So here we have these imaginary 20 test scores from chapter 1. So these are not anyone's actual numbers, these are just me making it up. So here's our data. I've got all these test scores. We've got a mean of 80, a standard deviation of 10, median, Q3, max, everything. So let me talk about the idea of a standard deviation before we move on, because in chapter 1, standard deviation was kind of not fully grasped by everyone. So I want to make sure to not leave it and just wait. So a standard deviation, when I talk about standard deviation, it is the average distance from the mean. So like our typical values, on average, how far were our values from the mean? It doesn't mean that all of our data was in there. It just means like, so like our average distance from the mean. So when you talk about standard deviation, it just means on average, how far were we from the mean? So if I take this example here, here is my mean of 80. So if I did a standard deviation of 10, so that would be 90, and that would be 70. So this right here would be me going a standard deviation this way and a standard deviation this way. And you can see it doesn't take up the entire graph. It just takes up like an average amount of our data values. It doesn't take up all of them. We missed a few on the end, but it does hit most of my values. So that's what a standard deviation is. It is, on average, how far are our values from the mean. So here's my mean, and on average, I was getting, about 10 from the mean, it looked like. So that's what we calculated here. So this is super important, and I want to make sure to understand what a standard deviation is. So 10 is a pretty big standard deviation. We were pretty wide. This was a test question. Like, if I have data values that are really close, like this is a really small standard deviation compared to like me having data values that are spread out. This one, to get an average, I have to go wider. So this would be a small standard deviation, and this would be a bigger standard deviation. Just to make sure we're all on the same page before we get too far away from this. Okay, so the idea of a standard deviation. I had a mean of 80, and I had an average distance of 10 from the mean. So I'm going to erase this so we can look at the problems here. Alright, so I'll circle these back. Okay, Biff had a score of 65. So here's Biff. He's one of these data points. What is Biff's percentile? So you just looked at that video, so we know what a percentile is. A percentile is all the values that are less than or equal to him. So there were 3 values that were less than or equal to him out of 20. So 3 divided by 20 is 15% of the values were less than him. So that would mean that he is in the 15th percentile. He is in the 15th percentile. He is on the lower end of that chapter 1 test score. All right, so we're going to go through building this definition of a z-score. So was Biff above or below the mean? So here's Biff at 65, and here's my mean of 80. So he was below the mean. By how many points was he below the mean? So by how many points was he below the mean? He was, the difference from 65 to 80 is 15 points below the mean. Okay? And then here's the standard deviation. So by how many standard deviations was he below the mean? So this is 1 standard deviation on this problem equals 10. So on this problem, 1 standard deviation was 10. So how many total standard deviations was he away? Well, he was 15 points below. So what I'm going to do is I'm going to take 15 and I'm going to divide it by my standard deviation, and he was 1.5 standard deviations below the mean. Okay, so he was 15 points below the mean, and since he was 15 points and 1 standard deviation was 10, he is 1.5 standard deviations below the mean. So he is outside of the typical average of values from the mean. He's low on the spectrum of scores, which we could see by the 15th percentile. We could see that as well. Okay, Marty scored an 88. What is Marty's percentile? So Marty was doing better. He scored an 88. So that would be this value there. So what are the numbers that are less than or equal to Marty? So what I like to do on these is I just count the numbers that were bigger than him. So there were 4 bigger. So that means less than or equal to him was 16 out of 20. And I believe 16 out of 20 is 80% were less than him. So that would mean 80th percentile. He was in the 80th percentile. Okay. So Marty, just based on our idea of percentiles, Marty is in the 80th percentile. He's doing pretty good. He is up there. He's better than 80% of the people. Okay, so let's get how many standard deviations was he away from the mean. So was Marty above or below the mean? Well, the mean was 80. So he was above the mean. By how many points was he above the mean? So he was at 88 and our mean was 80. So he was 8 points above the mean. Okay, so I'm 8 above the mean. How many standard deviations was he above the mean? So if I'll write it again, 1 standard deviation was 10 on this problem. So he was 8 away, and 1 standard deviation is 10. So he was 0.8 standard deviations above the mean. That's what Marty was. So he was 0.8 standard deviations above the mean. Okay. So we could calculate a percentile, or not a percentile, a z-score for anybody in this test score range. But we did it for these 2 scores. So Marty was 0.8 standard deviations above the mean. So he was almost a full typical score away from the mean. He was above average, positive value away. Okay, so here's this idea of a z-score. So a z-score, which is our important thing, a z-score is defined as the number of standard deviations you are above or below the mean. So your z-score is how many standard deviations you were above or below the mean. So on this problem right here, when Marty had a 0.8 standard deviations above the mean, what I'm going to say is that he had a z-score. His z-score equals 0.8. And since he was above the mean, so above the mean means he's going to have a positive value because he was positive above the mean. He was greater than. So Marty would have a z-score, a standardized score of 0.8. Let's go back up to Biff. Biff was 1.8 standard deviations below. He was below the mean. So Biff has a z-score equal to 1.5, but because he was below the mean, he's going to have a negative z-score. So a z-score that is negative means you are below the mean. A z-score that is positive means you are above the mean. So if we're talking about test scores, I want to have a positive z-score. I want to be one of the top ones. If we're talking about, let's see, something bad. If we're talking about cholesterol level, I want to be a low z-score. I want to have low cholesterol. I don't know why that popped in my mind. My wife makes me eat too healthy, I guess. So like a z-score, it doesn't necessarily mean that you're always good if you're a positive number. Maybe it's a bad thing to be positive. But on this case, it is a good thing to be above average on a test score. So there's that. So a z-score in this is the number of standard deviations you are above or below the mean. So Biff, we can see on this graph, was above the mean, and our Biff was below, Marty was above. So I want to be Marty. Okay, so let's write a formula for a z-score using what we just did on Biff and Marty, which is from a movie. It's called Back to the Future, if you're wondering where the heck these names are coming from. So write a formula for calculating the z-score. So I don't have room, so I'm going to write it right here. I don't know, just getting crowded. So my z-score, the first thing we did was we got how many points were we from the mean. So what we did is we took our value and we subtracted it from the mean. And then what we did is we took by how many standard deviations. And I did that by dividing by the amount of standard deviations. So a z-score is the value minus mean over standard deviations. And you're asking yourself, how many standard deviations are you above or below the mean? So that's what a z-score is. How many standard deviations above or below the mean are you? Okay, so let's do an example before we move on. I might even do one more on top of it. So Goldie had a score of 98 on the Chapter 1 test. Find and interpret. So interpret means like write a sentence, what that means. So Goldie had a 98. So here he is at a 98. He's doing pretty good. He's one of the top scores. That would not have been me. But you know, that's good, it's fine. Okay, so z-score. To get the z-score, he got a 98, and so we take our value minus the mean of 80, because remember we had a mean of 80 and a standard deviation of 10. So I would do 98 minus 80 divided by 10. So that would be 18 divided by 10 is 1.8, and it would be a positive value. So he would have a z-score equal to 1.8, and then I need to interpret what that means. So what does a z-score mean? That means that Goldie, again from a movie, so this is a weird name. So Goldie's test score, so his value was 1.8 standard deviations. So standard deviations. And then since it was positive, he was 1 point standard deviations above the mean. And that's all an interpretation is. So Goldie's test score was 1.88 standard deviations above the mean. That would be my interpretation. So a typical score was 1 standard deviation from the mean. We're in that range. He was 1.8 above the mean. So he is doing pretty good, which we can see on the dot plot. Goldie is doing pretty good. Okay. So Goldie is doing pretty good. Let's do a couple more. Let's do this low number. So maybe I'll embarrass myself here. So the 61. So let's make up an example on your page, just in your empty space. Let's say that Mr. Hamilton scored a 61 on the test. What is his z-score? Z-score equals blank. And what does it mean? What's the interpretation? Okay, so if I was doing this, the z-score would be my value minus the mean divided by standard deviation. So let me get my calculator, because I am making this up and I don't. So that's, I know it's negative. Oh, calculate. Come on. Okay, so that would be negative 19 divided by 10. I guess I'm silly because I know that that's just negative 1.9. I don't know why I'm making myself use a calculator. Okay, it's getting late at night and I need to go home. Negative 1.9. So my z-score would be a negative 1.9. So if I was to interpret what that means, that would mean Mr. H test score was 1.9 standard deviations below, so below the mean. Okay, and that's my answer. That would be the interpretation. What that means in layman's term is that Mr. H is way below average. Okay, he didn't do very good, which is okay. It's probably where I was on my chapter 1 test in high school AP statistics. I probably didn't do that good on the first test. But I grew to love statistics, and I really enjoyed it in college, and now, you know, of course I teach it all the time. It is my favorite class. Okay, but he is 1.9 standard deviations below the mean. He is far below. All right, let's do one more. So let me take my imaginary, let's say my daughter Ellie scored an 80 on the test. Because of course she did, because she's a 2-year-old genius prodigy that I teach statistics every night. I just go home and tell her how to do statistics. So of course she got an 80. Okay, so what is Ellie's statistics? I'm getting loopy here, I need to go home. It's already, what time is it? 8:30, dang. Okay, so Ellie got an 80. What is Ellie's z-score? So Ellie had an 80 subtracted from the mean of 80 divided by a standard deviation of 10. 80 divided by 80 is 0. 0 divided by 10 is 0. Ellie has a z-score of 0. What is the interpretation of that? The interpretation would be that Ellie's test score, so Ellie's test was 0 standard deviations from the mean. Okay, so if you think about it, of course I did this one on purpose. Ellie, if she is the average, Ellie scored the mean number. So of course she is going to be 0 standard deviations from the mean if she is equal to the mean. Okay, so if you have a z-score of 0, that just means, so that means it equals the mean. Okay, so if I get a z-score of 0, that just means I scored average on the test. I was equal to the class average. All right. So the 2.1 homework has calculating some z-scores. I think it uses it with some baseball teams from a stem plot data, so you can work on those. And interpreting it, it just means how many standard deviations were you above or below the mean. All right. Okay, so let me actually, on the next page, it looks like this, and I'm just kind of thinking about it. I don't really like the way they go about doing this to talk about this next topic. So what I'm going to do is I am not going to use number 7. I am going to use number 8 and 9 at the bottom of the page, but I'm not going to use number 7. So if you want to write some of this stuff in those blanks, or if you just want to write this in any empty spot, you can write it in the big ideas section, the important notes section before the check your understanding. That's good with me, but I'm actually not going to use this. So I'm gonna exit out of those two things. So let me kind of go back here. So I'm just going to do my own example. So we're going to go away from the z-score thing here for a little bit. What we're going to do is we're going to get into, how about I actually fill out number 8 first, and then we'll go. Let me see. My notes are looking different than what I wrote here. Let me check your notes real quick. Okay, your notes look like this, so that's good. All right, so let's summarize, and then I'm actually going to give you some examples. So let's talk about this. If you are given a list of data and you are told to add or subtract the same value from each data point. So we're going to go through the list. So let's just write this down. So what does that do? So we're talking about changes when adding, subtracting, multiplying, and dividing. That's what this little section is here. So what is the change to my shape when I add or subtract the same value? I'm going to give you some examples, but what I want you to write down for right now is that the shape stays the same. Okay, so the shape stays the same. What happens to the center of my data? So the center adds or subtracts by whatever value you do. So the center of the data adds or subtracts by the value. And what happens to the variability? What happens to the spread of our data? It stays the same. So let me give you some examples here real quick before we move on to the next one. So I'm trying to keep track of myself. So what happens if I add or subtract a value? So let me take an example here. Let's take this imaginary test here. Let's say our test had an average of 80 and it had a low value of 61 and a high value of 99. And let's say it was nice and symmetric, and it looked something like, well, that was a horrible, horrible drawing. I think I'm getting tired. Let's say it just looked something like this, like had some sort of distribution like this. Okay, so what happens if I add and subtract? Let's say I curve this test, and I curve the test by, what do I want to do? 5 points, because I just, for some reason, want to curve it. I didn't curve your test, by the way. They are what they are. So let's say I did curve your points. So what I'm doing is I add 5 points to every single number. So what happens if I add 5 to all points? What happens? So let's graph a new graph. So if I was to graph a new line, what would happen is the minimum would now be at 66, the center of our data would be at 80, and the biggest value, the maximum, would have been at 104 on the test. So if I added 5 to every single one of those, all I did was add 5 to every single one of those. They just all got bigger by 5, and that would be the same for every single one of these values in here. They would all just get bigger by 5, so the shape would stay the same. The center would go up by 5, and what happens to the variability, the spread? Well, the spread of our data was from 61 to 99, and now it's from 66 to 104. It stayed the same. So that's what happened there. It stayed the same. So that would be if I curved your test by 5 points. So that's an example of what I'm talking about here. Same, plus and minus, same. Okay, what would happen if I multiplied or divided by the same value? What's going to happen to the shape, the center, and the spread? So actually, no matter what, the shape stays the same. The center would multiply or divide by the value, and so would the variability. The variability would multiply or divide by the value. And I'm going to do an example for you. So the center and variability would multiply or divide by the data. So let me do an example. So let's do multiply or divide. So I'm trying to think of like an actual example of multiplying our data. That's not like a conversion. Let's just say I converted my data. So let's say I did it. So let's say that I had some data, and for some reason I had it in meters. And my data was, my lowest number was like 1 meter, and then I had 5 meters, and my biggest value was 14 meters, whatever. And maybe this graph was kind of uniform. Maybe it kind of looked like this. I don't know. I'm just making it up, so why not? Okay, let's say I converted my data to centimeters. So now my new graph is in centimeters. So I really hope I'm not embarrassed by this, but I think when you convert to centimeters, you would have to multiply by 100. That's right? Or is it 10? Now I'm doubting myself. Oh no. Maybe I should look it up real quick. Is it 10? Y'all are all yelling at me. It's 10, it's 10. What are you doing? Where am I at? Okay, centimeters to meters. That was supposed to be my easiest example. So is 100? Oh, I was right. Centa. Okay, trust yourself, Matt. Trust yourself. Okay, so I was converting to 100. So what that meant is I multiplied every single one of those values by 100. So now my lowest value is at 100 centimeters. My medium value is at 500 centimeters. And now my biggest value is at, well, I'm actually not graphing that quite right. Let me try again. So it would be more like this: 100 centimeters, 500 centimeters, and now I'm at like 1400 centimeters. I am pretty far away if I converted all my data to centimeters. So what would my data look like? Well, it would still look uniform. So again, the shape would stay the same. What happened to my center? So now, let's just say my center went from 5 to 500. So the center, even though if it's uniform, it wouldn't do that. So don't think about this too much. But the center basically multiplied by 100. It did what I did to everything. And what happened to the spread, the variability? So I did have a range. So I did have a range of 13 meters, and now I have a range of 100 to 1400. So now I've got 1300 as my range. So my range increased a lot. My range got multiplied by 100. So the shape stayed the same, my center x'd out, or my center multiplied, and my variability multiplied. So that's what would happen in that sort of, so anytime you multiply, the centers and spread change. When you add, the centers changes, but the spread just kind of stays the same. So me curving everything, the spread doesn't change. Okay. Another note here. Now we're good there. Okay. So let's just talk about that. So yeah, that's good. So let me do the check your understanding, and then I'm gonna stop this video and go home because yeah, should go home. Okay. So let's do the check your understanding, and this is kind of under that multiplying, adding, dividing sort of thing. Okay, so I have this amusement park in Pennsylvania. I'm not gonna try and pronounce that. Knoebels, yep, it's probably wrong. Okay, so they don't charge admission, or they don't charge admission or parking, but they do charge for each ride that you take. So that's kind of interesting. The dot plot is for 22 rides in a recent year. Okay, suppose you convert the cost of the rides from dollars to cents. I converted from 1 to 100. Describe what would happen to the shape, the mean, the standard deviation in cents. So what would happen to the shape when I convert from 1 to 100? Basically when I multiply every single value by 100. Basically just what we just did. So what would happen to the shape? The shape of this graph would stay the same. It's just those values would become 125 cents, 150 cents, 175 cents. The mean of the data, so the average of the data would be multiplied by 100. And so the mean would go from 1.705 to 170.5 cents. And then what would happen to the standard deviation? It's also going to get multiplied by 100. And so it went from 0.447 to 44.7 cents. Okay, so what happens when I multiply? The shape stays the same, but the average and spread get bigger. All right, now the managers decided to increase the cost for each ride by 25 cents. So we're adding, how did it do that? We're adding 25 cents to every ride. What would this do to the shape, center, and variability from question 1? So again, the shape never changes. Our shape remains constant. The center though, so we talked about the center moves with everything you do. So it gets added by 25. So it goes from 170.5 to 195.5. I'm just going to trust that that's right. And what happens to the variability? So when you add, it stays the same. So it stays at that 44.7 cents. So my average goes up, but the spread from biggest to smallest still kind of stays the same. Okay, now suppose you convert those questions from 2 to z-scores. I converted every single number to z-scores. What would the shape be? So what would the mean be for a z-score? So what would the mean be for a z-score? Z would equal what for a z-score? So this is that thing where Ellie was our test document. So our test subject document. I don't even know what I'm saying. But z, the mean has a z-score of 0. Z equals 0 for the mean. And what would the standard deviation in z-scores be? So what would the standard deviation be for a z-score? So how many standard deviations would I be? So if you're converting to z-scores and I want to know how many standard deviations I am away, a typical standard deviation for a z-score, so I don't think we actually got to that. A z-score, z-score standard deviation on, like every time I have a center of 0 and my z-score standard deviation equals 1. So how many standard deviations am I from the mean? I would be, a z-score of 1 would be 1 standard deviation from the mean. So your z-score would equal 1 if you're equal to the standard deviation. So that would be for all, you would have a z equal to 1. So on all z-scores, this would be for all z-scores, the mean equals 0 and the standard deviation equals 1. All right, so I think that about covers those two topics. So what is a z-score? A z-score is the number of standard deviations we are from the mean. So a z-score is just converting my number into how well I did compared to average. We talked about percentiles. So percentile is what percent of people are at your number or below you. So if you have a high percentile, you are above most people in that category. If you have a low percentile, you are below most people in that category. And then finally we talked about what happens when you add or subtract to a dot plot or a stem plot or whatever, and what happens when you multiply or divide to a data plot. And so those are those changes. All right, so that's a lot to go over, and I'm not here, but I just want y'all to look at those. I want you to attempt the homework. I want you to have questions for me on Monday when I'm back, because hopefully I am back. If you have other questions, please email me. If you're still watching this video, great job. I think I'm gonna stop and I'm gonna go home, I'm gonna get some rest, and I'm gonna feel better over the weekend. All right, I hope y'all have a good weekend.